Good day, ladies and gentlemen, guys and gents, and ladies. I hope that I find you well. This is the Maths Tutor Online. We're going to be talking about an introduction to projectiles and projectiles fired at an angle. Okay, so when we talk about projectiles, we're talking about basically something like this. Okay, an object that's fired, okay, at an angle, we can call it alpha or theta, to the horizontal, and with an initial velocity, okay, from the ground or even from above the ground, at whatever distance above the ground, is still a projectile. Okay, in the previous video we talked about projectiles which are fired vertically, okay, at 90 degrees to the horizontal, and in that kind of motion it goes up and comes back down to ground. Okay, so it's still a projectile, but a special type of projectile. It's not at an angle theta. Okay, it's at 90 degrees. Okay, so basic examples of projectiles are sports balls, cricket, rugby, soccer, okay, and other types of projectiles. You can talk about rocket propelled grenades, surface to air missiles, air to surface missiles, and to some extent ballistic missiles, okay, and also some types of domes like that protect nations from outside rocket propelled missiles. Okay, they're still projectiles firing at other projectiles. So a projectile is initial velocity that consists of a vertical and horizontal component. Okay, this diagram is an introduction of the components of a velocity and position, where a is the acceleration. Okay, you'll notice that horizontally the acceleration is 0, vertically is minus g, because we're going against acceleration due to gravity. The initial velocity, horizontal velocity, ux is u cos alpha. Initial vertical velocity is vy is equal to u sine alpha, and the final horizontal velocity is constant. It's just like the initial horizontal velocity. Final vertical velocity vy is u sine alpha minus gt. That's equation 2. Okay, r, which is the range and distance traveled horizontally, is ut cos alpha in the x direction. In the y direction, it's ut sine alpha minus half gt squared. Okay, so these equations are standard projectile terms, okay, that you're supposed to know, and they're basically derived from the equations of motion. Okay, I'm assuming that some of you have done high school introduction to projectiles, and if you have not done so, if you have not done equations of motion, okay, just Google them. Okay, we get projectile equations fundamentally from the equations of motion. Okay, and the equations of motion are just those three standard equations, but the difference is here acceleration is substituted with minus g. Let's just look at a quick example. A ball is kicked so that at the highest point of its path it just clears a fence a few meters away. The trajectory of the ball is shown below. Okay, the ground is level and the fence is 2.2 meters high. The ball is kicked from ground level with an initial velocity of 8 meters per second at an angle alpha to the horizontal. The air resistance is to be neglected. Part 1. Show that if the ball just clears the fence, the angle of projection alpha must be 55 degrees. Part 2 of the question. Find the horizontal velocity of the ball as it passes over the fence. Part 3 of the question. Calculate the total time for which the ball is in the air from instant it is kicked until it reaches the ground. You assume that g is equal to 9.8 meters per second squared. Okay, guys, this question was taken from the CCEA 2000 paper. I'm not so sure what examination board that is, but it's an advanced level British curriculum exam. Okay, don't worry about the year because projectile questions are standard. Okay, the laws of physics are constant. Okay, so these questions are random and they usually have something that they're looking for. Okay, they have something in common. So quickly, the solution to the first part. I hope you paused the video and you made some calculations. Okay, the solution that you get, this is the third process. At the maximum height, the vertical velocity is 0. We substitute values of vertical velocity component Vy is equal to 0 and initial vertical component U sine alpha. Okay, and we substitute values of acceleration, which is minus 9.81, vertical displacement, which is 2.2 meters, and we make alpha the subject of the formula. Okay, so there's the equation that we used, and there's the solution. Alpha is equal to 55 degrees. A part 2 of the solution, the third process, a horizontal velocity component is constant during flight, and it's u cos alpha, which is 8 cos 55, and it gives you 4.6 meters per second. The total time of flight, the third process that I used was we calculate the time it takes to reach maximum height and we multiply it by 2 to get the total time of flight. And at maximum height, the vertical velocity component is 0. Okay, so we can use that to get t, okay, from the equations of motion. Okay, and we know that the total time of flight will be 2 multiply the time to reach the maximum height, which is 2 times 0.668 seconds. So the total time there will be 1.34 seconds. Okay, so you'll notice that we were using third processes to come to our answers. Okay, but if you find it easier for you to memorize equations and just use memorized equations, okay, it's still fine as long as you can swallow them. But if you can't memorize the equations and you want to use a third process, you can use the strategy that I employed. Other important equations that you can memorize if you wish to, or that you can derive, because some exam bodies or exam questions might ask you to show that the greatest height is this. Okay, and they derived it from equation 2. Okay, and they say the vertical component of velocity is 0. Okay, so they used that to get the time. Okay, when they got the time, they substituted into the equation y is equal to ut minus half gt squared. Okay, and when they did that, okay, they then simplified that and got the maximum height. Okay, another important equation is the time of flight, which is identical to what we've calculated in the second part of the question. Okay, and the total time of flight is 2u sine alpha over g. Okay, there is the derivation. Okay, another important equation is the range. The range is defined to be u squared sine 2 alpha over g, where is the distance, the horizontal distance traversed by the projectile in its flight. And the maximum range occurs when alpha is equal to 45 degrees and is equal to u squared over g. The final equation you can take home is the equation of the trajectory, or the equation of the path of the projectile. And it's y is equal to x tan alpha minus gx squared over 2u squared cos squared alpha. From your trigonometry identities, 1 over cos squared alpha is equal to 1 plus tan squared alpha. So substitute that in place of 1 over cos squared alpha, you end up with that equation. Okay, This educational tutorial has been brought to you by eSchool Productions. Thanks for watching and stay studying. Please like and share this video, and you can hit me up on nwababa@gmail.com if you have more questions, or if there's anywhere where you want to go one-on-one tutorial. My Skype ID is kumlani.nwababa, and that's kumlani.nwababa. Okay, that's NQWABABA. My WhatsApp details are +263 773 002 835. Okay, you can donate to improve the quality of our productions. Donate for us to keep rolling out free tutorials for the disadvantaged communities. Okay, and my school email is as above. Okay, so what we want to do, guys, is empower those who are less privileged or those who are disadvantaged, who don't have access to classrooms, don't have access to the internet, those who don't have access to quality textbooks, okay, or ebooks. Those are the people we want to reach out. Okay, you're allowed to circulate this video and share it with as many people as you like. Okay, so that we can empower as many people as we can. People in Haiti, people in the projects in the United States, poor aborigines in Australia, poor people in Eastern Europe. We want to empower those in the jungles of Sri Lanka or Nepali, the jungles of India, and those in the African bushes. Okay, we know that they have access to WhatsApp. Okay, and they can easily circulate these videos. Okay, even without the presence of a teacher. Okay, they can still get access to these videos. Okay, so you can just donate to keep me pushing out these videos. Okay, to keep me rolling out more and more and more and more and more of these videos. Right now I think we're at count 10. Okay, our target is eSchool Productions is to reach over 1,000 videos. Okay, and for us to do that, we'll need lots of data, okay, which is highly expensive in the country that I'm in Zimbabwe. Okay, so definitely I'll need the money to keep this project going. Okay, because right now I'm putting in my passion. Okay, the money that I'm getting from teaching people locally, that's what I'm using to roll out more and more of these free educational videos. Okay, but I would and we would appreciate if you could chip in, okay, and help the less privileged people, those who are disadvantaged. Okay, those who can't access quality education. We want to give them quality on the internet. We want to give them quality on WhatsApp. Okay, and we want to give them these videos free. Okay, and the only cost that will be there is if you have the privilege to donate. You're most welcome, ladies and gentlemen, boys and girls, so that we can empower everyone educationally, okay, and improve standards of education worldwide. And rest assured, your monies will not go to waste. As you can see, we're rolling out quality educational, inspirational videos, and we hope to make them even more powerful, more inspirational. Okay, because this is our passion. Thanks for watching, and all the best for your June and November examinations. Okay, we hope that you get the best results, and if you do want to improve your grades, you can also hit me up and we can get to business. Stay blessed and stay reading, and stay safe.